girders like triangles. Triangles are strong. If you look at the underpinnings of a bridge, you'll see the girders arranged so that they brace themselves in triangular patterns. The reason for that is that triangles are fixed for lengths of sides and angles. There's no give in them. If you imagine a square, you could jiggle it. You could change the angles without changing the lengths of the sides, just by squishing it, moving it sideways. You can't do that with a triangle. It would be nice for purposes of understanding triangles if all triangles were right triangles. Then the definitions of the trig functions would be all that you would need to keep track of the information that's in the triangle. It might be, though, that the triangle that you want to study isn't a right triangle. There's two ways that it could fail to be a right triangle. It could have that right angle a little bigger than 90 degrees, or you could have the right angle a little less than 90 degrees. Either way, it still should be the case that you can determine numerically what is obvious geometrically, that there is only one triangle that matches a set of lengths of sides to a set of angle sizes. What we're going to be looking at this lecture and the next lecture are some techniques for solving oblique triangles. If it's not a right triangle, you can still use the functions that you're used to studying, sines and cosines, to come up with values of the missing parts of the triangle. So that's what we'll be doing today, the law of sines. Next time it will be something called the law of cosines. So take a look at the slides and see if these ideas make sense.